Inverter.
Welcome to ClickMyProject.com. The title of the project is Urban Functional Area Classification Model based on Multi-Model Machine Learning, and the abstract of the project is most of the classification methods of urban functional areas nowadays are only based on single source data analysis and modeling, which cannot make full use of the multi-scale and multi-score data that is easy to obtain, which aims at labeling urban functional areas images with a set of semantic categories based on their contents, has broad applications in a range of fields. Propelled by the powerful features learning capability of deep neural network, remote sensing image scene classification driven by deep learning has drawn remarkable attention and achieved significant breakthroughs. However, to the best of knowledge, a comprehensive review of recent achievements regarding deep learning for scene classification of remote sensing images is still lacking. Considering the rapid evolution of this field, this process provides a systematic survey of deep learning methods for remote sensing image classification. The urban functional area remote sensing images are taken as an input and analysis the urban functional areas through deep learning technique and analysis the urban functional areas from the images by using deep learning algorithm. And the deep learning algorithm was successfully trained the data and generate the result in form of matrices like accuracy, precision, recall and F1 score. And the flow diagram of the project is first we need to start the program and select the urban functional area remote sensing scene images, then it will apply into data pre-processing. In data pre-processing we are going to visualize the sample images from the every categories from the urban functional area remote sensing scene images. After that we are going to check the minimum height, minimum width and maximum width. After that we need to read all the input images and resize the images into uniform like 65x65 and then convert it into array. Then it will apply into feature selection or model selection. In that we are going to select our independent and dependent variable. After selecting the independent and dependent variable, we are going to split our dataset into training dataset and testing dataset. After splitting, it will apply into classification. In classification, we are using special case algorithm of deep learning algorithm like residual network 50, which is used to train all the urban functional area remote sensing scene images and predict the label of the input images. Then finally, it will generate the result in the form of matrices like accuracy, precision, recall, F1 score. The program was successfully executed in Anaconda Navigator Spider IDE, and this is our first module, data selection and loading module. In that we are going to read our dataset and visualize the sample images in our console. So these are all the input images of urban functional areas. So these are all the categories of our input images. So after that we are going to check the minimum height and minimum width, maximum height and maximum width that contains every categories from our input dataset. So after that we are going to select the independent variable and dependent variable. After selecting the independent variable and dependent variable, we are going to split our dataset into training dataset and testing dataset. So this is the independent variable train dataset and this is independent variable test dataset, and this is the dependent variable train data and this is the dependent variable test data. So then it will apply into classification method. In classification we are using the special case algorithm of the deep learning algorithm is Inception ResNet version 2. So in here we are applying the 100 different training epochs to train our input dataset. So the final accuracy of our Inception ResNet version 2 algorithm is 87%. And so these are all the visualization of our matrices. So this is the history of accuracy, loss. This is accuracy and validation accuracy, loss and validation loss, AUC, training AUC and validation AUC, and training precision and validation precision, training F1 score and validation F1 score, and finally training recall and validation recall. So after that we are going to find the confusion matrix. The confusion matrix which is used to explain the number of correct predictions and number of misclassification that we are obtained from our every category by using the inception resonant version 2 algorithm. So finally the user can manually choose on images, and our algorithm will going to predict the exact label of the input images, and these are all the variable results that we are using in our program.